Okay, welcome to ITS128. We're on week 14, chapter 10. Share my screen a little. Okay. So we're on chapter 10. Chapter 10 is a shorter chapter than chapter 9. We breezed through chapter 9 and we were making up lost time with the end of chapter 8. So is there anything you wanted to review in chapter 9? Okay. Okay, if not, we can always go back if you need to, but we'll get into chapter 10. So this is the wrong course. Sorry about that. Okay, chapter 10 is about handling exceptions. Okay, so error checking code is code that a programmer introduces to detect and handle errors that occur while program executes. Python has special constructs known as exception handling. Okay, so the important thing about exception handling is uh, it's a way so that you don't have to program all the logic for things that can happen. So you'll see that uh, it makes uh, it makes it easier to handle errors and exceptions that happen versus a lot of if-then statements. Okay, so let's look at the code right here. So this is an example where we're taking in user input. So user input is an area where you always want to have exception handling because it's hard to predict what a user is going to type in. Uh, especially if you're trying to take in a number and they put in letters and such. Okay, so in this case, this program block is going to keep accepting user input until the user inputs the letter Q. Okay, so in the try block, uh, they're asking for input, enter weight in pounds, and it's trying to cast that into an integer. Okay, and enter height in inches, and it's trying to cast that into an integer. Okay, and then it goes on with the rest of the math. So what can happen is if somebody enters something that's not even a number, uh, the casting to integer will fail. If they enter a decimal, then it'll also fail, right? So in the math, what it's doing is it's taking the weight and the height to do some math, right? So it's multiplying the height by itself, so squaring the height, and it's the weight divided by the square of the height. So in this case, it's casting to a float because we're doing a division here, and it's not going to end up as an integer. And then we multiply that by a constant 703, and then we're printing it out. Okay, so we can see the output here. So someone enters proper input 150 and 66. So no problems there, no exception handling happens. Okay. Person puts in A the second time around. So now A, it can't be cast as an integer, so an exception is going to get called. So it'll say could not calculate help info, which is in this except block. Okay. And then the second time around, we enter valid values 200 and 62. So it gets calculated properly, and then we exit properly. Okay. So in the most basic sense, you have the try and except. So try, as they say here, is any code. So this is code that's going to execute no matter what that you suspect might produce errors. And in the except, if any error occurs in the try block preceding it, then the code in this except block is what's going to get executed. Okay. So let's look at this real quick. Okay. So this will cause a value error because this is a string that you cannot cast to an integer. So then it moves on to the except block where it'll print an error message. So what this does is it controls the execution of your program. If you didn't have a try and except, your program would actually terminate at that point. Okay, so let's get to the first challenge activity. Well, okay, this is type the program's output. Okay, so we're trying to see what's going to happen based on the user input 7 and n. Okay, so in this case, we're calling input twice, casting it to 7. Okay, so the first time here, it gets a 7, and it does number 1 times 2, prints that. So that should be 14 because that's a proper integer. Then the second time, it gets an n, which it cannot cast, right? At that point, it cannot execute this because it'll move on to the exception block, and it's going to print x. Okay. Then after everything is completed, because it didn't terminate, it's going to continue with the program, and it should print E. Okay, having a problem with Zybooks again. So let me refresh this page. Okay, so second time around, it always gives you something slightly different, but similar concept. So in this case, we're going to print 8 times 4, 32. It's going to be an exception on M. So it can't print the next line. Then it prints the X. And then it prints the E. Okay. All right. Okay, no problem with Zybooks this time. Okay, let's skip to the odd number. Okay, so in this case, we're taking user input initially. And then, let's see, we're going to do more inputs here in a while loop. So we're going to go through this entire series here. So user input at this point is 1, and user input will be a string. Okay. And if the user input is not equal to Q, then it continues on. So now it's going to cast the string user input to an integer. So number is 1 and print number times 3. So that should be 3. Okay. Then it gets to the end of the loop, reads the next input, capital R. Then it goes back to the beginning of the while loop. It's not a queue, continues on. You're going to get an exception because you can't cast the R to an integer. So you're going to skip to the exception block. There should be an X. Okay. Then it continues execution. It reads in the 5. 5 times 3, 15. Right. Then it's going to go back again, reads new input, Q. Now it's equal to Q. So it breaks out of the while loop. So it's not going to execute the rest of this once it has this condition. So now it's going to print E. Okay, so let's check that. And that checks out. Okay, so let's see how many more units we got. Okay. So we'll just do one of these here. Okay, so this is, now we're going to enter some code. So add a try block that reads integer color intensity from input, outputs color intensity is the string followed by value color intensity. Okay, so these are examples of what the output should be. Okay, so oops, wait, intensity. Okay, equal to input. Yes, is that how? That's right. Okay, let's check that. Didn't pass. Oh, okay. I think I have an error here because I added an integer to this string, right? Let's see if that'll work. Hey, I still got an exception. So it could very well be that I'm not handling the strings properly. So when you do a variety of languages, you kind of forget all the different ways to do strings. Okay. So this is where let's take a look at, we'll just search for a reference. So maybe what I should be doing is a printf. So let's look at Python documentation. Let's look for an example. Okay, so we want to do a printf. Okay, let's try that. So there's going to be several ways to print this. So let's try that. So before peeking at the answer, let's let's see. I want to show you, what you would do as a coder. If you get stuck on something. So you'd look up some documents and find some references or look for other examples. Let's see. Could be D. Yeah. So this should be color intensity. Let's check that. Okay, so now it's happy. Okay, so all of the output matches. Yeah, so this type of print output is not the point of this challenge, but there's several ways to do it. You can use the F notation, you can concatenate the strings, and I probably didn't do it properly with just the plus. So yeah, many different ways to print. Okay, so next section. Okay, so now multiple exception handlers. Okay, so now the previous example, when I had the error, if you're running that in a IDE, it would tell you where the exception occurred, right? So I could clearly guess it was somewhere in the print. Sorry, let me silence. So it would clearly tell you what type of exception occurred, so you can narrow it down right away in the IDE. So that fits well with this next chapter, this next section, where now we're going to have multiple exception handlers. So now you can have different handlers based on what type of exception you get. So previously, no matter what the error was, it wasn't just a casting to integer, it was my bad print statement caused an exception and it executed the exact same code either way. But now you can narrow it down to do something different depending on what type of exception that you get. Okay, so let's run down to a challenge and then work our way back. So okay, here we're going to try to type the program's output. So first thing we see here is we see two different exception blocks. One is for value error and one is for zero division error, right? So it's invalid in math to divide by zero. Okay, so let's see what happens here. So again, we're doing a while block until user inputs end. So the first thing we do is 8, the string 8. So of course, that's going to fail right here. So it's a bad value. It's not an integer. So the first thing we should get is, let's see, yeah, so nothing else will print in the try block. And we get a V. Okay, then 0. So 0 is a valid integer. But when we try to print 60 divided by 0, we should get a 0 division error. Now 5 or 6, next to 6, so 60 divided by 6, truncating to integer should be 10 because that's a whole number anyway. Okay, then 5, okay, that's also a whole number, so no problem. And then we get to the end, and then it should print okay. So let's check that. Okay, and that checks out. So So this is an example, a simple example, but it shows you the how much time you can save with your exception handling, right? So more, the older languages did not have exception handling. So in that case, what you would do is you would always read user input as a string, and then you would have to do a series of tests against the string to check, is it an integer, is it zero, and have it all in your program logic. And if you missed one type of test, then your program would fail. So it's a lot easier to handle with uh, exception handling built into the language. Okay, so now let's do one of these challenges where we're going to actually write some code now. Okay. Okay, write an exception handler to catch value error and output area cannot be negative for square rooting. That'd be an irrational number. Write an exception handler to catch zero division error. Okay. So in this case, output cannot be negative. Okay. I'm just thinking the cases that we have here is to check for negative for the input, catch and output square area negative, but we're not checking that it's a string, right? Uh, and here also, uh, this part is fine, zero division error. You're only going to get to that uh, once you pass the initial check, right? But our job here is to just write the exception handlers, right? So we'll do that anyway. So in this case, you'll see if someone inputs a string, they'll still get the value error. And if this is the standard output, it'll be a little misleading, but the exception handler will still catch that, right? So let's go copy some of this code here. Like that. Okay, fix these. Okay, let's check that. Okay, so it checks out. So in this case, you can see their tests do not have a string check, right? So this is just an example, so it's not a criticism against it, but when you're writing code like this, yeah, you should see that because you're taking user input, it could be a string, and you probably want to show a different message for that. Okay. Okay, so let's get to now raising exceptions. Okay, so for this one, let's look at this first piece of code here. Okay, so consider the BMI example. User enters a weight and height, and that outputs the corresponding BMI. Okay, so now we want to ensure valid heights and weights, so should not be negative for sure. So we'll need some error checking code, right? So as I mentioned before, a naive approach to adding error checking code is to intersperse if-else statements throughout the normal code. So if you had a language that didn't have exception handling, that was the only way to do it, which is why modern languages all have exception handling so that the code is much cleaner. So particular concern is the highlighted code. So you can see here, right? If weight less than 0, print invalid weight. If height less than equal to 0, print invalid height, right? So it says the concern here is then print BMI harder to see. Furthermore, the second check for negative values before print BMI is redundant and prone to program error caused by inconsistency with earlier checks. So, yeah, so in this case, we're doing a less than equal to versus a less than, and a 0 height is not valid either. Yeah, so you can see because the if else, right? Once you have a if else to move on, now you're further down the nest, and then you're doing an if here, and then if it passes, you know, you'll need an else here to continue on, and it'll continue nesting down, right? So you have to account for all the logic where, for both sides of it, and it's not really accounted for here properly. Okay, so now the next example shows the same error checking carried out using exception handling by using the new braze construct, right? So now there's no if else. Well, there's an if else, but just to raise the exception, not for the flow control of the program itself. So as soon as a weight is less than 0, then it'll say invalid weight, right? So it raises that. So in this case, you assume that if you're not raising an exception, you're proceeding at the same level through the program, right? Then you're going to do a height check, and then you can raise it if it meets this condition. If not, it continues on. Okay. And the key here is you're constructing a value error, which is why the value error is being executed here. Right. So what you're doing is the value error, you're constructing it with invalid weight, right? So when it does print exCPT, that's what it's printing, invalid weight and invalid height in this case. So it prints that first, then prints the could not calculate health info. So you can see that here. Okay, so let's go on to the challenge. Let's see how many challenges here. Okay, so we'll do one quick easy one. So we're just gonna type the output. So we cast to integer right away, 60, right? So it's not less than 0, so it's not gonna raise this. So average max heart rate, 220 minus 60, and it's gonna print that. So VBG colon space 160. And then it's not going to do the exception block. So that should be good. Okay. So now let's do the next challenge, coding challenge. Okay, so integers, seats per row, and num rows are read from input, representing the number of seats per row and number of rows of seats in a class. So in the try block, raise a value error exception with this message if it's less than or equal to 0, and same for number of rows. Okay, so let's go copy some code here. Okay, so we're going to say seats per row. So if seats per row is, in our case, it's less than or equal to, okay, then we're going to, this will be the message. Seats per row, number of seats per row must be positive, okay? Now, next one is number of rows. I print this message. Okay, let's check that. Okay, so all of the tests passed. So with these negatives, it passed. And then they did a zero check to make sure we got the boundary correct, that it's less than equal to and not just less than. Okay. Exceptions with functions. Okay, so this is a key message right here. So the power of exceptions becomes even more clear when used within functions. If an exception is raised within a function and is not handled within that function, then the function is immediately exited, and the calling function is checked for a handler, and so on up the call hierarchy. Okay. So like I said earlier, if in your main program you had an exception, then your program would just terminate. So it's the same when you call a function, anytime there's an error in the function, your function terminates immediately. Right? So what Python does is, and you can have functions being called, many levels deep. So whenever something terminates, there's a check for, anytime there's an error, there's a check for an exception handler. So if you have no exception handlers, eventually that function terminating will cause your entire program to terminate. But that's where it'll keep going up. So what this means is uh, you don't have to have error checking in every function. So at some level, you want some error checking, but your functions can be more general and more simple where you don't necessarily have the error checking in every function. Because in general, you want to keep any function as simple as possible, and functions are called by many other parts of code, so you want it as general as possible. So you could have a function that brings in a number, but you're not going to want to check all the different criteria for the number, because depending on where in the program you're calling it, you would use it differently. So let's look in here. Okay. So in this case, we're getting weight and height again, right? So now we're encapsulating all of the logic for weight in this get weight function. Okay, so in this case, this function is specific to get weight. So we do want to, we're doing all the checking for weight there, right? So weight cannot be negative. It casts to an integer. And if it's negative, then we're going to raise an invalid weight value error. This cast here will result in raising of the value error also. So if a person puts in anything besides an integer, it's also going to raise a value error, but not a custom value error with this message, right? So same way for the height. Okay, so it's doing all of that here. So let's see what happens with the output. With valid output, everything's normal. With invalid weight, it cannot calculate. Enter weight, invalid height could not calculate. Okay, so this one does not have a challenge. Okay, so looking at this code, like I said earlier, if someone, in this example, they don't have it, but if someone input a non-integer, then you would get a value error, right? But what would it print here where it says print that? So it's not going to be invalid weight. It's not going to be invalid height. So let's go back to here. So basically, now you're going to invoke a built-in error for that. You're not raising a custom error. You're going to get a built-in error. So you're going to get this is probably what you're going to get. Sir, oh no, we want to use the exception information. Okay. Okay, so when someone enters 150, just says could not calculate health info. Oh, because we're not printing the exception. Let's see, are we? Yeah, okay. So in these previous examples, there's nothing that's printing the value of the exception. Let's come back here. Right. So one thing you could try is execute this with non-integer and see what this prints. So it's going to print the built-in message from Python for the unable, something like, unable to convert to integer or something like that. Okay. So now, finally block. Okay, so program wants to execute code regardless of whether or not an exception has been raised in a try block. Okay, so for example, if an exception occurs while reading data from a file, the file should still be closed, no matter if an exception interrupted the read operation. The finally clause of a try statement allows a programmer to specify cleanup actions that are always executed. Okay, so let's look at this here. Okay, so if no exception occurs, it's going to run the try and run the finally. If an exception occurs, everything in the try stops immediately from where the exception occurs. the accept block is handled, and then the finally block is run. So yeah, the best example is things like closing files. So if you're reading input from a file, you get something you're not expecting, you throw an exception, you're gonna quit the try block, right? You might have a file closed in the try block, but if you hit an exception, the file will not be closed. It'll remain open. So instead of putting a close in a try block, let's say you could put the close in the try block and the accept block. So instead of doing that, we have a finally block where you can do all the cleanup that you want to do no matter what happens. So here you have an example where you're going to be closing a file. Right? And oh, there's no challenge here either. Okay. Yeah, this is a much shorter chapter. Okay, now the last concept is custom exception types. Okay, so when raising an exception, you can use the existing built-in exception types, like we did with value error with a different message. Okay. Alternatively, a custom exception type can be defined and then raised. Okay. So here's an example of a custom exception type. So if you had a much more complex application that you're coding for, uh, depending on what type of domain that the application is handling, yeah, it, it would be helpful to have custom exceptions to really see what's going on. So in this case, we have a less than zero exception. So we define it as a class. So we're extending exception. Then now we can raise a less than zero error. Okay. So like I said, programmer creates a custom by inheriting from the built-in exception class. Okay. So this one, there's no activity at all, but I'll show you an example of where this can be used. Let's see. So I mentioned here earlier when we're raising exceptions that we can raise invalid height, invalid weight by checking if it's less than zero, right? Uh, when you do this integer cast and someone put an invalid integer, that would also be a value error. So what will happen is all of these errors will result in this accept value error block being being executed. Okay, so now if we go back, sorry for skipping around, but if we go back to the custom, this is a less than zero error. So that's a new type of exception that we made. So if we use that back in this example, we could raise that custom less than zero error, in which case you can have a different accept block for that and print a different message, right? So the first one would say that's not a valid integer, blah, blah, blah. And then the other one would tell them that the value is wrong. Okay, so that's the end of exceptions. So we still have a half an hour. Let's see. No challenges here. Okay, this is an optional lab. Maybe we can look at the optional lab, but is there any questions? Anything to review this chapter or chapter 9? No? Okay, let's look at this optional lab. Okay, exception handling to detect input string versus integer. The given program reads a list of single word first names and ages, ending with a -1. Oh, okay, so user ends the input with a -1 because they can put in any number of names and ages that they want and outputs that list with the age incremented. The program fails and raises an exception if the second input on a line is a string rather than an integer, right? So for the name, it's a string, so it's letting you enter anything you want. The second input has to be an integer. Okay, so now if there's an error, uh, we're not going to print any message. We're just going to output 0 instead. We're just going to substitute, right? Okay, so in the fix me, we're going to add a try catch block. Okay. And if the second input is a string rather than an integer, we just do int. But actually just do a try here. So we're going to try this. So if this fails because it's not a integer, then it's going to assign a 0 to age instead, right? Okay, so let's check that. So in this case, I'm just doing it simply. So I put this entire thing in the try block, and I'm just checking for any exception. Let's say it wants something, if it wants something more specific than that. I need to put in some input. So okay, so I guess it's been doing stuff. So now let's try do the auto grading for it. Okay, so we pass, right? So in this case, it was all, we had the bad case of Mary Beth. So Mary is 0 here. Same thing here. We had Sarah Sims. So 0, 0, 0. So it all passes. Okay. So we did it just in a simple way, but you know, you might want to check for more specific it, depending how complex your try is. This is really simple. The only part that could really well, there's two parts that could fail here. One part is if the is obvious is the casting to integer. The other one could be if the two parts, this is an array and there could be nothing in the index one, right? So that's a different kind of exception that can happen. So maybe, okay, so let's try see what happens. So if I execute that, okay, it adds 1 to 4, so I get 5, right? And if I put in a non-integer, I get a 0 there. So now if I don't put the right number of inputs, I still get a 0 because because it because what happened is in this try block, any exception it took and just assign age equals 0. Okay, so let's try experiment with this. I'm going to open up another iBooks tab. Look at exceptions and let's go to raising exceptions. Okay, so let's check this like I was mentioning earlier. So what if okay, so now I'm only handling value error and I'm gonna print the exception message. So let's see. Let's start with a valid one. This one, okay. So this is the generic message if we're using the built-in value error without overriding the message. So it's telling you invalid literal, right? And it continues on with 0, so that it continues on. We're just printing an extra message here. So now let's try where so now we failed because this is an index error and we don't have an exception handler for index error, so it fails, right? So let's try something here. So let's copy these two lines. Okay, so in this case, if we get an index error, let's try printing that exception message and assign age to 99. Okay. I don't know if I need to restart. Let's see what happens. I guess I do. Oh, yeah, because it's exited. So run it. Now do our checks just to make sure. Yep, so that works as expected. So now if we have an index error, because I only have one input, it's print, that's the generic message for an index error, list index out of range. And Now it says ASDF 99, which is what we overrode to. Okay. So yeah, so you can see all the different ways you can use exceptions. And in this lab, this was not part of it, but we could use the lab to see how it's handling these different parts, right? So the part I was getting at is depending, your try block is normally going to have many lines of code. So so you need to look at all the parts where it can fail, right? So I spotted the index and the value. Pretty much nothing else that could be an exception here, because we're just doing a simple addition to an integer here, right? So if you had more lines in this code, yeah, that's where you want to look at all the different things and cover the exceptions, right? Uh, you can have you can have a default exception handler, right? Because you're never gonna catch every possible thing, let's say. So instead of failing, you might want a default exception handler. So let's say we don't account for uh, index error, right? So I think we can just do the base class exception. Okay. So let's see what that does. Okay, so in this case, we're not defining the exception. We're just saying, let's catch value exceptions to that. Everything else, we don't know whatever exception comes our way. So now I'll go straight to that. Okay, so it's still being handled now because anything outside of that exception, this is the base class of all exceptions. So this gets executed no matter what, for any exception that there is. That's not a value error. So it still executes that, right? Whereas if you didn't have that, if you didn't have that, the program terminates. Okay. Any questions? No? Okay. So let's look. Yeah, the semester is winding down. We we have just 2 sessions left, right? Chapter 11, chapter 12. So have a good Thanksgiving and I'll see everyone next week.